To research Nibiru, Nemesis, Hercolubus, Wormwood, Planet X, Planet 7, Planet 9, anything like that is a real possibility. Let's discuss some basics you should not and cannot avoid. This is the physical scale chart most people saw in the old Encyclopedia Britannica of all of the different planets. It includes Pluto there for a reason. I'm including it just to show you bizarrely how much scale you have to work with. Now they're shown in the order that they show up in. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. And the scale's pretty close, but not quite. Let's look at the next image. First, anything larger than the Earth would take about 5 years to enter our solar system and would be visible to everyone. I'd like to point out that in the lower right-hand corner there are all the planets, and that's the Sun. We're going to zoom in a bit, but I just want you to see the scale and then see how messed up the scale is from our perspective, which is what you're dealing with. There are the planets again, and there's the scale. Now we're only just looking at the 8 planets. Pluto's a little bit tinier than all of those. And if something was entering the solar system, it wouldn't dart around playing peekaboo or always being opposite the side of the Sun or just off to the right or the left, or somehow being in front of the Sun but be smaller than the Earth or larger than the Earth, because the scale's wrong. And it wouldn't require the vision of some chosen one, or only some people are special to see it. That's a form of elitism. And it wouldn't require that you deliberately go out and find a cheap webcam that doesn't compensate for the optics problems or compensate for things such as the inevitable thing we all talk about, which is our old friend lens flares. It would require a set of eyes, and I'm going to show you why, but the thing is, the way we detect planets already is what you'd have to do first. Not using a cell phone camera or anything like that, because you have to do it the same way you do it now. So here are the problems you have to actually really solve. If you can see the moon and the sun often enough, and most of you do, okay, well, you have to learn to locate and confirm all of the planets first so as to exclude them. You have to know their positions and physical size scales. And as you can see, the physical scales here are that all the planets, including Pluto if you want to jam it in there, could fit between the Earth, which is on the extreme left, and the moon, which is on the extreme right. And this is almost a scale. It's actually got more room than that. So you'd have to accept a couple of things here. You have to learn the apparent angular size of planets as seen from the Earth relative to the moon as comparison. This is a pretty good one. Now, obviously, Venus is much closer than Jupiter and Saturn, but they're enormous and they're much, much further away. Mars is pretty close. Venus and Earth are about the same size. Mars is actually somewhat smaller. So, obviously, if you were going to do any kind of real star watching or planet locating, the first thing you'd have to do is find out where they are and learn to recognize them pretty much by color, and you need to use at least a pair of binoculars. That means you have to throw out using cell phones and webcams, because Jupiter is enormous and so are Saturn, and they're smaller than some of the craters on the moon for scale. Now they do have variation in size, and you can look up those things on a couple of links below so you can get an idea. There's a lot of variation in some of them because they have really extreme orbits compared to the Earth. Again, because their size changes, they're not orbiting Earth, they're orbiting the Sun. That's something you'd have to also kind of accept unless you just don't want to do any of this. But here are the comparisons. Now this is a chart. If the circle was on your monitor, it was 10 centimeters wide, then you'd have to view it from 10.3 meters away, because you want this thing to be at a scale distance of 103 times its diameter maximum, which is the moon. The moon, sun, min, and max all fit in that scale. And you can see there that at the bottom there's Neptune. It's a pixel and a half across. Uranus is a little bit larger. Mercury is actually discernible as being a circle rather than a dot. Saturn just a little bit more. Mars just a little bit bigger. And a moon almost visible. Jupiter with its moons are technically naked eye visible if you have very good vision, and Venus is, because human 20/20 vision acuity, or considered normal vision, only takes up about the same diameter of resolution as Venus. The International Space Station is small enough that you might be able to see it only. So literally everything, including the 2 largest planets orbiting our Sun, visibly in the sky are tinier than the International Space Station. You can go out and look at the sun and the moon and see them. Unless you can visually, absolutely see the International Space Station and resolve it at least a little bit, you don't know whether you're looking at a star, a planet, or literally some random object, or even an orbiting satellite. You need to have a telescope or a pair of binoculars. Binoculars are preferred. And literally, I can send you, there's a link here to you to download this, hang it up on a wall, and tell yourself you can discern these things, which is the word people use. If this circle was on your monitor and it was 10 centimeters wide, you'd have to get 10.3 meters away, or 30 feet, in order to get an idea of just how hard it is to see Jupiter. We see it as a blinding dot if it's good opposition with the sun, and that happened recently. And that indicates the diameters in minutes and seconds, apparently. Ever look up 1 minute of arc? So, and again, it would take 5 years of observation before you could confirm it's coming here. And the way you do it is you compare it to the background stars. And the only way you can do that is to know where the other planets are so you don't get them confused. Consistently, people who look this subject up don't look up where they're supposed to be. And they also don't realize the diameter changes. Again, Jupiter is still tiny visually. And we know it's there. And you can get out a pair of binoculars and see it, or a telescope. The scales are very, very much tilted to you having to look at something that's at the outer limits of your visual acuity. Again, special people out there don't exist, and the cameras don't exist. You need to get binoculars, and you need to stop using webcams. And I've debunked enough of them to know that no, they usually just get the moon at night, and that's about it. Next. Then maybe you can research Earth tilt influenced by other planets. Or is it happening now? These are the actual tilts of our real planets that we have. Mercury's really close to the sun and is basically bound not to rotate off axis, I suppose. Venus a little bit less, goes the opposite direction. Earth, it's tilted pretty heavily, but it's bound to its moon. Mars, similar thing. Jupiter has a bunch of moons, but it's pretty much almost perfectly straight up and down compared to its orbit around the sun. Saturn, not so much, and it has a ring that should stabilize it. Uranus is almost tilted in total opposition, and Neptune's bordering on the same angle that the Earth and Mars have. And if you are surprised to hear about that, let's start at the beginning. To research planets in our solar system, much less hypothetical ones, you must learn to realize that you have to treat them as real possibilities, not a cause, and you have to discuss the basics. And those basics include things that you may not want to look up, including just how hardcore the scale is for every other planet out there, visually, and why it took us so long to realize these things. Thank you for watching. Have a good day. Good luck with that.